Video, we'll be discussing about Physics Paper 2, 8th level structured question, 2019 May-June, variant is 23, the subject code is 9702. 1 part A, define resistance. So we know that resistance is equal to voltage by current. So potential difference per unit current or voltage divided by current. Then the potential difference, a potential difference of 0.60 volt is applied across a resistor of resistance 4 giga ohm. So what is giga? Giga means 10 to the power, mega means 10 to the power 6, so giga means 10 to the power 9. So giga is 10 to the power 9, mega is 10 to the power 6, and kilo is 10 to the power 3. So giga means 10 to the power 9. That is 10 to the power 9. So 4 into 10 to the power 9 ohm. And we need to find the current. So we need to find the current in picoampere. So what is pico? So giga means 10 to the power 9, mega means 10 to the power 6, kilo means 10 to the power 3, then deci means 10 to the power negative 1, centi means 10 to the power negative 2, milli means 10 to the power negative 3, micro means 10 to the power negative 6, nano means 10 to the power negative 9, and pico means 10 to the power negative 12. So micro is 10 to the power negative 6, nano is 10 to the power minus 9, and pico is 10 to the power minus 12. So pico is 10 to the power minus 12. So we need to find the current in picoampere. So resistance is equal to voltage by current. So current is equal to voltage by resistance. So we know the value of voltage and the resistance. And the resistance is in giga, that is 10 to the power 9 ohm. So after calculating, we get the current as 1.5 into 10 to the power 10 or 115 10 to the power 12. So 10 to the power 12 is pico. So 150 picoampere. Then the energy transferred when charge Q moves through an electrical component is given by the equation energy is equal to VQ or QV, where V is the potential difference across the component. Use the equation to determine the SI base unit of potential difference. So we need to find the SI base unit of potential difference V. So for energy, let's suppose we can consider any energy. Let's suppose kinetic energy. Kinetic energy is equal to half mv square. So half has no unit, mass has a unit of kilogram, and v, that is speed, has a unit of meter per second, so meter per second square. So overall it becomes kg meter square per second square. That is the unit for energy, that is the SI base unit of energy, that is kg meter square per second square. And q is the charge. So we know current is equal to charge per unit time. So charge is equal to current into time, and charge has a unit of coulomb, but we don't need coulomb, we need SI base unit. So the SI unit of current is ampere and the SI unit of time is second. So the overall SI unit for charge is ampere second. And V, we need to find the SI base unit of V. So V is equal to kg meter square per second square by ampere second. So the overall equation becomes, or the overall SI base unit of voltage becomes kg meter square per second square, and this is divided by second, so per second, so per second cube, and since it is divided by area, so per area, that is per area. So this is the overall SI base unit for energy. Number 2, part A resultant force F moves an object of mass m through a distance s in a straight line. So resultant force, mass m, and distance s. So the force gives the object an acceleration a, so that its speed changes from its initial speed u to the final speed v. So force acts on an object of mass m and acceleration a, distance traveled is s, and initial speed is u, and the final speed is v. So state an expression for work done by the force in terms of ma and s, mas. So we know that work done is equal to force and the distance moved in the direction of the force. For example, the force is in this direction, so the distance must be covered in this direction. So work done is equal to force into distance, and here we have given distance as s, so fs, and we know that force is equal to mass into acceleration. So resultant force is equal to mass into acceleration, and it is S. So the overall work done is becoming MAS. So overall equation is MAS. That is work done is called MAS. Then the distance is in terms of A, U and V. So distance. So we know that S is equal to UT plus half AT square. Then V square minus U square is equal to 2AS and V is equal to U plus AT. Now, which equation do we need to use? So we need to express our equation in terms of distance S. So S is, this is not the answer, or this is not the equation that we need. Then acceleration U and V. So acceleration U, there is no V, so this is wrong. But here there is acceleration U and V, so we can use this equation. That is V square minus U square is equal to 2AS. So V is the final speed, that is V. U is the initial speed, 2 acceleration is A, and the distance is S. So we need to express S in terms of these terms. So S is equal to V square minus U square by 2A. So V square minus U square by 2A. So we express S in terms of A, U and V. Then kinetic energy. So use your answer from in 1 to show that the kinetic energy of the object is given by kinetic energy is equal to half mv square, or the speed square. So you must need to use your answer from part 1. So what is the answers from part 1? So first of all, we need to erase this. So the answer from 1, that is work done is equal to MAS and distance is equal to V square minus U square by 2A. So we usually know that power is equal to work done by time taken, or energy by time taken. So that means work done is equal to energy. So work done is equal to energy. So work is equal to energy. So work done is equal to MAS. That is work done is equal to MAS from part A. So and S is equal to this expression. So instead of S, we can substitute this value in terms of instead of S. So instead of S, we substitute this equation, and after solving, A and A cancels, and the overall equation becomes m v square minus u square by 2. So m v square minus u square by 2, that means half m and final speed square minus initial speed square, or simply we just write in terms of v speed square, SPWD square. So half, this is mass and speed square. So MASS into SPWD square shown. So we need to show that, so this is shown, and we have used part 1, that is already mentioned. Then a ball of mass 0.040 kg, so we have given the value of mass, is projected into air from the horizontal ground as illustrated in figure 2.1. So the ball is moving from the horizontal ground to the air at point Y. The ball is launched from X and has a kinetic energy of 4.5 joules. So at point X, it has a kinetic energy of 4.5 joules. At point Y, the ball has a speed of 9.5 meter per second. So at point Y, it has a speed of 9.5 and it has speed, that is meter per second. Air resistance is negligible. So that means for the upward movement of the ball, there is no air resistance. Now, for the movement of the ball from X to Y, draw a solid line on figure 2.1 to show the distance moved. Label this line D. So first of all, what is the distance traveled by the ball? So from point X to point Y, what is the distance traveled? Let's suppose this is X and this is Y, and this is the distance traveled. So this is the overall distance traveled, and the displacement is from the starting point to the ending point. So what would be the distance? Distance is the total distance covered by the object, that is this distance, and we need to denote this by D. Then displacement, label this line S. So displacement is from the starting point to the ending point. So from the starting point to the ending point, a straight line, and this is denoted by S. Then by considering the by conservation, so by consideration of energy transfer, determine the height of point Y above the ground by consideration of energy transfer. So we know that initial energy is equal to final energy, and initially at the starting point we have only kinetic energy, because we have given the information for kinetic energy, that is the initial energy. That means we have initially kinetic energy, that is 4.5. And what is the energy at point y? And you have to remember that at point y it is not mentioned that it is the maximum height. So since it is not mentioned that point y is the maximum height, let's suppose this is the maximum height and point y is not our maximum height. So we know that at maximum height the speed is 0. At maximum height the speed is 0. But here we have given the value of speed at point y. So we have given the value of speed at point y, that is 9.5 meter per second. Since we have given the speed at point y, so it has obviously a speed of 9.5 meter per second. That means it is not the topmost point or at the greatest height. And we know that at the greatest height the velocity is 0. So at point y we have, as we have given the value of speed, so we obviously have kinetic energy, and since it is gained some height, so it has gravitational potential energy. So at point y it has kinetic energy and gravitational potential energy. So gravitational potential energy is mgh and kinetic energy is half mv square. So we know the value of mass that we have given initially, that is the mass of the ball. So mass and the gravitational field strength is 9.81. So it is given in the data booklet, and you need to look at that what is the value. For now it is 9.81 and the height is h. So the vertical height is h, and we need to calculate this vertical height h plus half mv square. So we know the value of mass, that is 0.040, and the speed is 9.5. So at point y, that means at point y the speed is 9.5 meter per second, and so this is the speed is 9.5 meter per second. So after calculating we get the value of h as 6.9 meter, that is the vertical height at point y. So this is the height, that is 6.9 meter per second. 6.9 meters. So since this is a height, so its unit is meter. So for part 3, on figure 2.2, sketch the variation of kinetic energy of the ball with its vertical height above the ground for the movement of the ball from x to y. So basically we need to draw the kinetic energy against height graph from point x to point y. So from point x to point y. So at point x the vertical height is 0. That is, the height is 0 and it has a kinetic energy of 4.5 joules. So at point x, it has a vertical height of 0. So the height is 0 and the kinetic energy of 4.5 joules. So 4.5 joules, it has some kinetic energy. Then at point y, it has a vertical height h and it has obviously some kinetic energy, since at point y we have given the value of speed. So at point y it has kinetic energy and the height. So it has height h, that is already mentioned, that is height h, that is this height h. And what is the value of kinetic energy? So what is the value of kinetic energy at point y? So we don't need to give the exact value or sketch the variation of kinetic energy of the ball with its vertical height above the ground for the movement of the ball from x to y. Numerical values are not required. So we don't need to give any numerical value. Now what is the kinetic energy at point y? So we know that at point y it has a speed of 9.5 meter per second, so it obviously has some kinetic energy. But since we know that initially it has kinetic energy, and after this kinetic energy is distributed to gravitational potential energy and kinetic energy, that means at point y it has less kinetic energy when compared to the initial kinetic energy. So comparing to the initial kinetic energy, that is at point x, point y has less kinetic energy. So the value of kinetic energy would be less. So initially it has a kinetic energy at this point. So let's suppose the kinetic energy at y may be at this point, or this point, any point that is less than x. So we have just drawn any random point, that is this point, that is the kinetic energy at point y at height h. So then we need to draw a straight line for this graph. And why we draw the straight line? Because if we consider the initial kinetic energy, then Ekx is equal to final kinetic energy, that is Eky plus gravitational potential energy. So we write gravitational potential energy in terms of mgh. So kinetic energy at point x minus kinetic energy at point y is equal to mgh. So mgh. Now we can simplify this equation and express this equation in terms of h, that is height would be kinetic energy at x minus kinetic energy at y by mg. Now, so why we consider this graph as a straight line? Because if we consider the kinetic energy at y have a constant value, so this value is a constant and we need to draw the kinetic energy. So the sketch the variation of kinetic energy with the vertical height. So kinetic energy, that is the overall kinetic energy. So this is the overall kinetic energy against h. So mass and gravitational field strength has a constant value. Gravitational field strength has a value of 9.81, so it is a constant, and mass has a value of 0.040, so mass is also constant. That means here we can see that height is directly proportional to kinetic energy at x minus kinetic energy at y, or simply height is directly proportional to kinetic energy. So height is directly proportional to kinetic energy, and since it is a proportional graph, so it have to be a straight line. So we have drawn a straight line, that is the kinetic energy against height graph. Now question number 3. A cylindrical disc of mass 0.24 kg has a cross-sectional area A as shown in figure 3.1. So this is our disc and it has a cross-sectional area A and it has a mass of 0.24 kg. This is the disc and the force X of 8.9 Newton is acting like this, and the force is acting at an angle of 30 degree. So for this force, that is 8.9 Newton, we need to find the horizontal and the vertical component of the force. So what would be the horizontal and the vertical component of the force? So what is the horizontal component? Horizontal component is 8.9 cos 30 and the vertical component will be 8.9, that is the force, sine 30. And this disk is moving at a constant speed of 0.60 meter per second. So the disk is on the horizontal ground as shown in figure 3.2, force X of magnitude 8.9 Newton acts on the disk in the direction of 30 degree to the horizontal. So this force is acting at an angle of 30 degree to the horizontal, and the disk then moves at a constant speed of 0.60 meter per second. So the disk is moving at a constant speed of 0.60 meter per second. And what is constant speed? So we know that at constant speed, acceleration is 0. And since acceleration is 0, so we know that resultant force is equal to mass into acceleration. Since acceleration is 0, so the resultant force is 0. That means at constant speed, since the resultant force is 0, so the forward force is equal to backward force. Determine the rate of doing work on the disk by the force X. So what is the work done by force X on the disk? So rate of doing work. Okay, it is rate of doing work. So work done by time taken. That is the rate of doing work. And the work done by time taken, that is the work done and the rate is time. So work done by time taken is power. So we need to find the power. And to find the value of power, we can use the formula work done by time taken, but we don't know the value of work. And if we just find the value of work, then we don't know the value of time. So we can calculate power by using the other formula, that is power is equal to driving force, that is force into velocity. So what is the driving force? So the velocity is in this direction, that is 0.60. So 0.60, so that is in the horizontal direction. So we need to must use the horizontal component of the force. That is the horizontal component of this force. So what would be the horizontal component? So if we break the forces into its component, then the vertical component is 8.9 sin 30 and the horizontal component is 8.9 cos 30. So the horizontal component is 8.9 cos 30. There is the horizontal force and the speed, that is 0.60. So after multiplying, we get a value that is 4.6 as the power to two significant figures or one decimal place. Then the force X and the weight of the disc exert a combined pressure on the ground of 3500 Pascal. So this is the pressure. Calculate the cross-sectional area of the disc. So we need to find the area. And what is the combined force? So force X and the weight. So what is force X? So This is our force X, that is 8.9, and the weight. So weight is acting vertically downward. So the weight is acting vertically downward. And what is the weight? So it has a mass of 0.24. So we know that weight is equal to mass into gravitational field strength. So 0.24 into gravitational field strength, that is 9.81. So the weight is acting vertically downward. And weight and force X. So what is force X? Whether we consider this force X or we need to find the vertical component of the force. We need to find the vertical component of the force because since weight is acting downward, so we need to find a force that is acting downward. So what is the vertical component of the force X? X vertical would be 8.9. Since it is the opposite side of the angle, so 8.9 sine 30. Sine is opposite and cos is adjacent. So 8.9 sine 30 plus the weight. So both the forces are acting downward. So 8.9 sine 30 plus the weight, that is 0.24 into 9.81. 0.24 into 9.81 plus 8.9 sine 30. That is 8.9 sine 30. So this is our combined force and we need to find area. So pressure is equal to force by area. So area is equal to force by pressure. So this is the total force and the pressure is 3500 Pascal. So what we get the value of area? The area is 1.9 into 10 to the power minus 3 meters square. Two significant figures. Third law describes how the forces exist in pairs. That okay, the forces exist in pairs. One such pair of forces is the weight of the disk and another force y. State the direction of the force y. So what is Newton's third law? So let's suppose an object A exerts a force on object B, then object B will exert an equal and opposite force on object A. So the forces are equal in magnitude, equal. The forces are acting in opposite direction and the forces are acting on mutually opposite bodies. So if an object A exerts a force on body B, then body B will exert an equal and opposite force on body A. So the forces act on different bodies. Forces act on different. So the forces are equal in magnitude, acts in opposite direction, and the forces are acting on different bodies. That is, if an object A exerts a force on object B, then object B will exert an equal and opposite force on object A. So the forces are equal in magnitude, acting in opposite direction, and acting in different bodies. So by Newton's third law, one of the such pair of force is the weight of the disk. Let's suppose this is our disk and the weight is acting downward. So what is the and another force is y. State the direction of the force y. So here we can see that the forces are acting in opposite direction. That means for Newton's third law, forces are acting in opposite direction. Since forces are acting in opposite direction, so the weight is acting downward. So force y, that is this force y, must act upward. So the force must act upward. Now the name of the body on which force y acts. Now what is the name of the body on which force y acts? So let's suppose the disk, and the disk has a weight of W. Here we can see that the weight force is W, and what is and the name of the body on which force y acts. So we need to find the name of the body on which force y acting. So here we can see that the weight is acting on the disk. So first of all, let's suppose this is the ground. Let's suppose this is the ground, and let's suppose this is our ball. Instead of disk, we consider that this is our ball. So the ball is in air. Now the weight of the ball is acting downward. Now on which object is the weight is acting? So let's suppose this is our ball and the weight is acting downward. So on which object is the weight is acting? So the weight is obviously acting on the ball that causes it to move downward. So the weight is acting on the ball. So W on ball. So the weight is acting on the ball. Or we can write this as weight acts on ball. Since the weight is acting on the ball, and we know that forces are acting on different bodies. So force y, that is acting upward. So we already mentioned its direction, that is upward. So force y must act on other object. since the weight is obviously acting on the ball, weight acts on the ball, and since the forces act on different bodies, so the weight is acting on the ball, so y must act on other object. So y acts on, so and the other object, so weight is caused by earth, so earth or planet, so y must act on earth. Now I would explain this. Let's say okay, so the weight is acting on the ball. Let's suppose the ball is in air and the ball is moving downward. Why the ball is moving downward? Due to the weight of the ball. And where weight is acting, or on which object is the weight is acting? The weight is acting on the ball. So weight is acting on the ball. So force Y must act on the earth. So since here we can say that they are the Newton's third law of forces, that means they are equal in magnitude, acting in opposite direction, and acting on different bodies. So the forces must act on different bodies. So the weight is acting on the ball, so the force Y must act on the earth. And why it is acting on the earth and not the other object? Because weight acts on the ball, and the weight acts on the ball due to gravity of the earth. Due to gravity of the earth or due to earth. So weight is acting on the ball due to earth or due to gravity of the earth. So weight is acting on the ball due to earth or due to the gravity of the earth. So the weight is acting due to gravity of the earth. So y must be acting on the earth due to weight. Due to, so the y must act on the earth due to the weight. Therefore, the y force is acting on the earth or on the planet. Weight is acting on the ball, y is acting on the earth, and they both are acting on different bodies. 4. This force is related to electric field and it is not in our syllabus. So electric field is not in our syllabus. Before discussing the question number 5, so what are the waves formed for the open end pipe, and for one end is closed and the other end is open? So for the open end pipe, so as both the ends are open, so at the open end we know that antinodes are formed. At the open end antinodes are formed, and at the closed end nodes are formed. At the open end antinodes are formed, and at the closed end nodes are formed. So for the open end tube, at the open end antinodes and at the closed end nodes. So open end antinodes are formed, and the first wave is formed like this. And this has a wavelength that is, and the wavelength that is covered is lambda by 2. And if we just draw the full wave, then the full wave would be like this. So this is the full wave, and if we divide this, then the wave that is formed is lambda by 2. Similarly, here we can see the full wave is formed. That is one wave. And how we determine that this is one wave? Because these 2 points have the same speed, same displacement from the rest position, same displacement, and same direction of motion. So this point is moving in this direction, that is in this direction, and this point is also moving in this direction. So same displacement, same speed, same displacement from the rest position, and the same direction of motion. That means both the points are moving in this direction. That means since they are moving in the same direction, they have the same displacement, so the points form one wave, or the points are in phase. So one wave is formed, then 3 by 2 wave, or 3 by 2 lambda, that is 1 lambda and half the lambda. So this is half the lambda. Then for the closed end, one end is closed and the other is open. So the wave that is formed, or the wavelength that is covered, is lambda by 4. So the wavelength that is covered is lambda by 4. So if we just draw this complete wave, then let's suppose the wave is from this position, and this is the complete wave. So this length is lambda by 4, and this length is like this. So this is lambda by 4. If this total wave is lambda, then this length is lambda by 4. So lambda by 4, then at the close end node and at the open end node, then the next wave is formed as 3 lambda by 4. So 3 lambda by 4, that is this much wave is covered. So this is 3 lambda by 4. Then this is 1 lambda, and this is lambda by 4. So lambda plus lambda by 4 is 4 lambda plus lambda by 4, that is 5 lambda by 4. So you need to remember these drawings and you need to practice these drawings. Now for question number 5, a vertical tube of length 0.60 meter is open at both the ends as shown in figure 5.1. So this vertical tube is open at both the ends. An incident sinusoidal wave, sound wave of single frequency travels up the tube. So a wave is traveling up the tube. Duration of incident sound wave. A stationary wave is then formed in the air column in the tube with antinodes at both the ends and node at the midpoint. So it is already given that the antinodes are formed at both the ends and a node is formed at the midpoint. So at the midpoint there is a node, and obviously at open end there is antinode that is formed. So antinode and antidode, and if you just join the points, then the wave is formed would be that if you just join the waves, join the points, then this is the wave that is formed. And it is also mentioned that the wave that is formed is a stationary wave. That is, a stationary wave is formed, then formed in the air column. So a stationary wave is formed. Explain how a stationary wave is formed from the incident sound wave. So how stationary wave is formed? So incident wave is reflected from the end of the tube. So incident wave is reflected. Now the incident wave and the reflected wave overlap or interfere or superimpose to form stationary wave. So the incident wave is reflected from the end, then incident and the reflected wave overlap and superimpose or interfere to form stationary wave. So incident wave is reflected from one end or from the end. Incident wave is reflected, and the incident and reflected wave then overlap, interfere or superimpose to form the stationary wave. On figure 5.2, sketch a graph to show the variation of the amplitude of the stationary wave with the height h above the bottom of the tube. So the height is moved in such a way that it is measured from the bottom of the tube. So the height is measured from the bottom and to the top of the tube. So from the bottom to the top of the tube. So we know that at the open end, antinodes are formed, and for a stationary wave, antinodes have maximum amplitude and nodes have zero amplitude. So nodes have no displacement, so they have zero amplitude. So nodes have zero displacement and so zero amplitude. And what is the overall length of the tube? So for the tube, so what is the overall length of the tube? So the total length is 0.60 meter. So the total length is 0.60 meter, and antinode, that means the maximum amplitude is at the beginning and at the end. So at the beginning and at the end there is maximum amplitude. So here we don't need to give any numerical value, just the maximum amplitude is at the start and at the end. That means at 0, when the length is 0 from the start, from the bottom. So when the length is 0 from the bottom and when the length is 0.60 from the bottom, the amplitude is maximum. That is antinode. So antinode and antinodes have maximum amplitude and nodes have zero amplitude. So this point is a node that have zero amplitude, and node is formed at the half end or 0.60 by 2, that is 0.30 meter. So node is formed at the 0.30 meter and it has zero amplitude. Then we need to just join the points like a wave. So this is the wave that is formed for the stationary wave. See, for the stationary wave state, the duration of oscillation of an air particle at a height of 0.15 meter above the bottom of the tube. So what is the oscillation of the air particle at a height of 0.15 meter? So the total length is 0.60, the half is 0.30, and at this point that is 0.15 meter. So 0.15 meter, what is the vibration of the air particle? Now we need to remember that sound waves are longitudinal wave. So sound waves travel parallel to the direction of vibration of the medium. Since sound wave is moving in this direction, so the vibration of the medium is also in parallel with the sound wave. So the vibration of the medium is also in parallel with the sound wave like this. So the vibration of the medium is in parallel with the sound wave. Since sound wave is a longitudinal wave, so the vibration of the medium is parallel to the sound wave. So the particles vibrate parallel, and if you see this clearly, then the movement we can see that it is vertical with respect to the tube. So vertical along the length of the tube. Then the phase difference between oscillations of a particle at a height of 0.10 meter and a particle at a height of 0.20 meter above the bottom of the tube. So what is the phase difference at a height of 0.10 and 0.20 meter? So let's suppose this is, so the total length is 0.60, this is 0.30, and let's suppose this is 0.20 and this is 0.10. So 0.20 and 0.10. So what is the vibration of the particles that are separated by this distance? So here we can see that the particles are within the node, so they have a phase difference of 0 degree. That means this is 2 node and the particles are within the node. So the phase difference is 0 degree. But let's suppose the particles are separated by a node. The particles are separated by a node, then the phase difference would be 180 degree. So if we draw this, then let's suppose this is the stationary wave and this is the base. So if let's suppose the 2 points, let's suppose this node and this node, if the 2 points are within the same node, then the phase difference would be 0 degree. But let's suppose the points are separated by a node, that means this is 1 point and this is 1 point, and these 2 points are separated by a node, so the phase difference would be 180 degree. But for now, since the 0.10 at 0.20 and 0.10, the particles are within the node, that is this node and this node, so the phase difference would be 0 degree. So the phase difference is 0 degree. Then we have given the speed of the particle, speed of the wave, that is v. Calculate the frequency of the sound wave. So v is equal to f lambda. So f is equal to v by lambda. So v by lambda. So what is the wavelength? So for the wavelength, if we look at this wave, then for this wave, the total length that is covered is half the lambda. If we draw this clearly, then the total wave is formed like this. So the length that is covered is half the lambda. Length that is covered is half the lambda. That is lambda by 2 is 0.60 meter. 0.60 meter. So lambda would be 0.60 into 2, that is 1.2 meter. So the lambda would be 1.2 meter, and v by lambda is frequency. So the frequency is 280 hertz. Then the frequency of the sound wave is gradually increased. So frequency increases. Determine the frequency of the wave when a stationary sound wave is next formed. So when a next stationary wave is formed, we need to determine the frequency when the next stationary wave is formed. And here it says that the frequency increases. Since the frequency increases, so lambda decreases. Or in simpler words, frequency is gradually increased. So since frequency is increased, so more waves are formed. So let's suppose the wave that is formed in this tube is like this. and as frequency is increased, so let's suppose this is our tube and frequency is increased. So the next wave that is formed is at the open end antinodes are formed and at the closed end nodes are formed. So at the open end antinodes are formed. So the wave would be like this. Now for this wave we can see that there is one node, but for this wave there is 1 2 3. So 1 2 3 node. So this is not our wave. So since there is one node, so the next wave have to be two node in between is. So again, let's suppose if you just drop, then at the open end antinodes and at the closed end nodes, and here two nodes are formed. So one node and the next node. Since there is one node, so the next wave must have two nodes. So if we join just the nodes and the antinodes, then the wave that is formed like this. So one, two nodes, and at the open end antinodes. So this is the next wave that is formed. And what is the wavelength? What is now the wavelength? So the total length that is covered is, so here we can see that the total length that is covered is, so the 2 points have the same displacement from the rest position and the same direction of motion. So one complete wave is formed, that is lambda. So the total wave that is formed is lambda. So here lambda is formed, that means a total wave is formed. So lambda is equal to the total length of the tube is 0.60. So the total length is 0.60. So the lambda is 0.60 since one complete wave is formed. So for this wave, lambda is equal to 0.60. This wave is formed with two nodes and frequency is equal to v by lambda. So the frequency is 570 hertz. So for the next wave, since this wave has one node, so the next wave must have two nodes, and after this wave, the next wave must have three nodes, and this would increase. Ohm. So we know that resistance is equal to voltage by current, and the unit for resistance is ohm. That is ohm. Ohm is equal to, this unit of voltage is volt, and for current it is ampere. So ohm is equal to volt per ampere. So volt per ampere or ohm. Now a battery of EMF E and internal resistance 1.5 ohm. So 1.5 ohm is the resistance, internal resistance is connected to the network of resistor as shown in figure 5.1. So this is connected. Resistor X has a resistance of 8 ohm, and resistor Y has a resistance of 2 ohm. Resistor Z has a resistance of RZ. The current in X is 0.60 ampere. So at point X, it has a current of 0.60 ampere, and at Y, it has a current of 1.8 ampere. Calculate the current of the in the battery. So since the two resistors or both the combinations are arranged in parallel, so for parallel circuit, the voltage is same. And the current would be that I is equal to I1 plus I2, and the current in this junction is 1.8 ampere, and for this junction or this circuit it is 0.60. So 1.8 plus 0.60, so the total current of the battery is 2.4. That means they join to form an overall current of 2.4 ampere. Then the resistance RC. So we need to find the resistance RC, this value of resistance. So first of all, we know that in parallel combination, the voltage is same. That means the voltage at this point is equal to the voltage at this point. So what is the voltage at X? So Vx is equal to voltage. We know that voltage is equal to current into resistance. So the current is 0.60 and the resistance is 8. So the overall voltage is 0.60 into 8. So the voltage is 4.8 ampere, 4.8 volt. That means at this point, the total voltage is 4.8 volt. That means V at this junction is 4.8 volt. So we know the total voltage and we know the total current. So what is the resistance? Since Y and Z are arranged in series, so within themselves, they are arranged in series. So the total resistance would be, total R would be 2 ohm plus RZ. So again, we can use the formula resistance is equal to voltage by current. So the total resistance that we have calculated is 2 plus RZ. That is the total resistance across this junction is equal to voltage, that is 4.8 volt. And since in parallel circuits the voltage is same, by current, that is 1.8. So 1.8. So what is the value of Rz? So it is 4.8 by 1.8 minus 2. So it is separated by 2. So the overall resistance becomes 0.67 ohm. So the resistance is 0.67 ohm. Two significant figures. Then what is the EMF? So EMF would be, so for EMF, we know that in parallel combination, the voltage is same. So the voltage that we have calculated is 4.8. So the voltage is same, that is 4.8. Now this voltage plus the voltage across the internal resistance. So what is the voltage across the internal resistance? So voltage across internal resistance, we refer this as I, is equal to current into resistance. So what is the resistance? Resistance is 1.5 ohm, 1.5 ohm. And what is the current? So what is the value of current? So we need to use the total current, since this current and this current joins to form a total current of 2.4 ampere. That is this current plus this current, 0.60 plus 1.8 becomes a total current of 2.4 ampere. So what is the voltage across internal resistance? So 1.5 into 2.4. So the overall voltage becomes 3.6 volt. That is the voltage across the internal resistance. Now we need to calculate the total EMF. So total EMF is equal to total potential difference plus potential difference across the internal resistance, or I. So the total potential difference is 4.8 volt that we have calculated here, and the potential difference across the internal resistance is 3.6. So 4.8 plus 3.6, the overall voltage is 8.4 volt. That is the EMF is 8.4 volt. That is the in parallel combination, or the voltage, that is this volt or this volt, they are same. So that is 4.8 plus the voltage across the internal resistance. So the overall voltage becomes 8.4 volt. That is 8.4 volt. Resistor X and Y are each made up of wire. The wires in the two wires have the same length, so they have the same length and are made of the same metal. So since they are made of the same metal, so they have the same resistivity. Now determine the cross-sectional area of X by cross-sectional area of Y. So we know that resistance is equal to resistivity into length by cross-sectional area. So cross-sectional area would be resistivity into length by resistance. So cross-sectional area of X by cross-sectional area of Y is equal to resistivity into length by resistance of X by resistivity into length by resistance of Y. And if you just simplify this, then it will be resistivity into length by Rx divided by resistivity into length by Ry. So Ry. Now we can write this in the form that is resistivity into length by Rx into, since it is divided, so if you multiply, then Ry would come to the top and divided by rho L. And since they are made of the same material, so they have the same resistivity, so resistivity cancel, and they have the same length, so length and length cancel. So the overall equation becomes resistance of Y by resistance of X. So what is the resistance of Y? Resistance of Y is, so for Y, we calculated the resistance, okay. So what is the resistance of Y? So resistance of X is 8 and the resistance of Y is 2. So resistance of Y is 2 and the resistance of X is 8. So if we just divide this, then the ratio becomes 1 by 4. That is the answer. The average day speed of the free electrons in X by average day speed of the free electrons in Y. So Q is the elementary. So first of all, I is equal to NAVQ, where Q is the elementary charge, that is 1.6 into 10 to the power minus 19 coulomb. So Q is same, there is constant for both the wires, for both X and Y resistors, and N is the number density. So X and Y are made up of the same metal. So since they are made of the same metal, so N would be same. And what is number density? Number density is the number of free electrons by volume. So number of free electrons per unit volume. So since that they are made of the same metal, so number density is same. That is the number of free electrons per unit volume is same. So it is also same. So we can write the formula since they both are constant. So if we do our working at this place, then V is equal to I by NAQ. That is Vx, and for Vy, so the average day speed of X by average day speed of Y. So average speed of x, that is divided by, so since it is so divided by average speed of y, that is iy by naq. So since they are both divided, so if we just multiply this, then we need to just reverse up and down. So naq y by iy. So q is same, number density is same. So the overall equation becomes current at x into cross-sectional area at y by cross-sectional area at x into current at y. So current at x. So what is the value of current at x? So current at x is 1. So the current at x is 0.6 and the current at y is 1.8. So 0.6 and 1.8. So for x it is 0.6. So for x the current is, so for x the current is, so what is the value of current at x? Current at x is 0.6. So current at x is 0.6 by current at y, that is 1.8. And what is the cross-sectional area at x and y? So for the cross-sectional area, so is the value that is given to us, the cross-sectional area. So yes, we have found that the ratio of cross-sectional area of x by y is 1 by 4. So cross-sectional area of x by y is 1 by 4. So area of x by area of y is 1 by 4. So what is the area of y by area of x? Y by x would be 4. X by y is 1 by 4. So y by x would be 4. So area of y by area of x is 4. Just it is 4. So the overall equation becomes 0.6 into 4 by 1.8. So if we just do our calculation, then 0.6 into 4 by 1.8. So the ratio that we get is 1.3. 1.333, that is approximately 1.3 to significant physics before discussing question 7. So for particles are made up of leptons and hadrons. So hadrons are made up of baryons and mesons. So leptons are not made up of quark, and so they are not affected by strong nuclear force, while hadrons are made up of quark, thus they are affected by strong nuclear force. And examples of leptons are electrons and electron neutrino. And for baryons are made up of 3 quark and mesons are made up of 2 quark. So 3 quark. So for proton and neutron are the example of baryon. Proton is made up of up down quark and neutron is made up of up down quark. And for mesons are made up of 2 quark, that is matter and antimatter. Then up, top and charm quark have a charge of plus 2 by 3e. Down, strange and bottom quark have a charge of negative 1 by 3e. And all of these have a mass of u by 3. Number 7. A sample of radioactive substance may decay by the emission of either alpha radiation or beta radiation or gamma radiation. State the type of radiation in each case that consists of leptons. So which radiation consists of leptons? So for beta decay or beta radiation, so let's suppose neutron changes to a proton, and so proton has a mass number of 1 and a charge of 1, and since proton is emitted, so to balance this, a beta minus particle or an electron is produced, and with electron we know that antineutrino is emitted. So with electron antineutrino is emitted, and with positron neutrino is emitted, and obviously energy is emitted. So here we can see that the lepton, that is antineutrino, is emitted. Similarly for beta plus decay, that is proton 1 1 changes to a neutron 1 0, neutron plus electron, that is 0 e1 plus neutrino plus energy. So here we can see that neutrino is emitted or antineutrino is emitted, and they consist, or they are leptons. So beta decay consists of leptons, that is neutrino or antineutrino, then contains quark. So for alpha decay, let's suppose any random element, let's suppose chlorine. So, or if we just consider any random element, let's suppose X. X has 22 mass number and a proton number of 8. and it decays by alpha decay. So as alpha particle is emitted, the proton number is decreased by 2. So the overall proton number becomes 6 and the mass number decreases by 4. So the mass number becomes 18 and so particle Y is formed, that is particle Y plus alpha particle. So alpha particles are emitted. Now for alpha particles, here we can see that contains quark. That means alpha particles consist of protons and protons or neutrons. So protons are made up of up, up, down quark and neutrons are made up of up, down, down quark. So for this decay, they consist of protons, they consist of quarks. So the decay would be alpha decay. Then cannot be deflected by electric field. So electric or magnetic field, gamma radiations are not deflected. Then have a continuous range of energy rather than discrete amount of energy. So alpha particles have discrete amount of energy, while beta particles have a continuous range of energy. So the continuous range of energy would be beta particle. And why beta particles have a continuous range of energy? Because this energy is shared between this beta particle and this neutrino. So this energy is shared between beta particle and neutrino. Similarly, this energy is shared between beta minus particle and antineutrino. So since the energy is shared, so they have a continuous range of energy, while alpha particles have a discrete amount of energy.